Hello everyone. We are just doing a demo and recording the session, so to see how the system is working. So essentially, you're seeing in the we are recording the robot and also the screen, so you can see what we're going through. So first of all, as we have a home sensor, we are doing the home search to find the home position, and to do that, we just go to home search, and it extends the arms as you see, the laser arm, and after that we just set the where we want to search for the home. We just set the speed to 0.5 because it's kind of faster than 0.1 rpm. Both forward and backward, and the degrees, because we know that we know relatively where the home position is, so we just search for this first 70 degrees, but we can do a full search like 360, but that doesn't matter, just takes more time. So we just do everything, and then we then just zero the position, because currently we just want to define the current position as set 0. So that current position, that our 0 position, and just set the protection, and then we start the rotation. And as you can see now, the robot is rotating. We should just wait until we find the home position, because we are looking at the edges. When we are finding the home position, we are looking at the edges, because it's kind of sensor, you either connect or disconnect, so we find the home position twice, but we just look at the final home position we find, and that's because only one time, so we are always going to use that. And as you can see now, it's returning, and during return, because currently we found the home position, which is called 53 degrees, but as I told you, we just look at the final time we find the home position, which is around 26. So that's going to be our home position. So now we just write the home position, which is 26.45. And then now we want to do the scan mode, so we just switch to scan mode, and we just want to set the scanning parameters. So because we want to scan the first seam, so we essentially we're going to scan 120 degrees. The thing is that because currently we are not at home position, so when we do the start rotation, we first go at home position, then we do the scan. So this 120 degrees is relative to the home position, which as requested, we put the torch when the torch is exactly at the bottom, that's our home position. So we just set the kind of trajectory definition to 120 degrees, and the speed is the same. And because we want to connect to the camera, we also bring up the Visual Studio. We just double check that because that's the first scan we are doing, we double check that we are our variable is equal to 1, which means that we are doing the first scan, and then just start rotation. And we are kind of running the complete laser scan, which just gets the data, filters the data and everything. And now, as you see, it stopped at home position. Now from this point, it's going to scan 120 degrees. So because the arms are 120 degrees shifted together, so actually when we scan 120 degrees, the laser scan is going to be at the bottom because it's 120 degrees before the torch. And then as you see on the screen, I mean, the scan is going to finish. As you see, I mean, the scan is finished, and then the filtering has been done as well. And because in the first scan we are going to do the piecewise linear fitting, it takes around 3 minutes until we do the fitting, and you know, we fit kind of the trapezoidal figure to the groove we found. So we just wait that amount, and in the meantime the robot is returning to the home position. So always from now on we return to home position. So after, yeah, I mean, we're just waiting for it. I mean, it shows the time it takes, but yeah, as I told, it's around 3 minutes, so I think it's going to be soon, and it's going to be finished pretty soon. So the next steps we are going to afterwards, because we are doing this on the PC, because you know the Raspberry Pi is not powerful enough, it takes more time, maybe around 20 minutes to do the same thing. So we are doing it on the PC, but then we upload everything on Raspberry Pi to just make it faster, make the process faster. So then in the next step, yeah, we're just going to upload everything. So in here it's took around 137 seconds, and now it's just generating the trajectories, and now everything is finished. As you can see, they exited the program, and so we just, in here we have connected to Raspberry Pi, which IP, and you can see the IP. And then if you go here, we just upload, because you know we have found the groove, and we have found the, you know, kind of the midpoints and breakpoints, so we just upload them. Yeah, it's just replacing, because previously there was a file there. It's just replacing that, the midpoints as well, and also the whole trajectory, because we found the trajectories. That's, yeah, just all the trajectory of the groove, and it's like in a 2D dimension. Which is called X and Z. Z is kind of the height, and X is the width of the groove. So we just upload them. Just double check, because you know these programs are currently separate. I mean, we run something on PC, something on Raspberry Pi. We should just make sure, okay, both of them, they are using the same scan number. So just make sure it's one. Now we are going to just send the parameters from here. These parameters from Raspberry Pi to the MCU. And as you can see, we are receiving the data. As you can see, it's kind of the, and every time when we receive, and if you have when we have received the data, the kind of LED blinked, but currently we have received every data. And as you can see, this Q theta 0 and this Q theta 1, these are the beginning and ending of this kind of the seam which we detected. Okay, so then the data has been sent. You want to send again?
Yeah.
Okay, the data has been sent, right? Okay, yeah. And yeah, in the next step then, yeah, we just the thing is that sometimes when we send the data, okay, just one thing. So this one, I think this one is only showing is because in FreeMaster the data is received. I think maybe probably this is not connected to the correct variable. But yeah, we just sending again to make sure if the data is being sent, but because it's showing 0 in here, but actually in FreeMaster, yeah, so it's only on the HTML side. We are just showing the wrong variable. That's why it's called 0. So everything is sent okay. Now we are going to welding mode. So first we can just set the parameters. Currently for now we just set it to around, yeah, minus, yeah, that's okay, minus 45, because that's where the kind of seam ends, and we just make it because we just want to, yeah, when during welding it's going to be a lower speed, just make it 0.1 both forward and backward, so we can see that okay, it can do both uphill and downhill. Yeah, just make the amplitude of the slider just 0.1 centimeter, and also frequency to 1 hertz. Okay, now we just go to welding mode, and as you can see the torch extends, but I don't know if it's clear in the video, but the tip of the torch, it's not exactly in the groove, but as you can see where we go, yeah, now if you start rotation, now when we start rotation, when we just reach the groove, just want to make it here, yeah, you can just make it here, yeah. So when we reach that part of the seam which we are using it, kind of the first part of the weld, you can see that the torch just displaces and goes into the groove. So we are controlling the height and also controlling it at around the center. Yeah, we can just to just make it more clear, we'll just bring the video, just record the recording so we can see. And we can change the offset of the, for example, we can make it more near or more, currently we just put an offset so the torch just keeps the same offset from the groove. Yeah, so it's returning to the home position now. I mean, after the welding, just returns to the home position again, and then yeah, and then when the seam ended, just we retract the arm a bit so it doesn't touch anything, just to make sure everything's okay. Now in the next step we are to just emulate a multi-pass scenario. We assumed that okay, we have welded that section, so we are going to just put something as a weld, and then we are going to do the scan again and then do the welding process again. no, it's this plastic. Oh, sorry. Okay. Okay. So now we just go to scan mode again, and when we do scan mode, as you see, the welding arm is going to get retracted because during scanning I just want the laser arm to be extended. Okay, so again we just set the angle to 120 degrees because we just want to scan the full path, and we just increase the speed again. And then we just make sure the laser program is ready. And as you can see, the var has been changed to number 2 because we did the first pass. It automatically just gets updated to number 2. And as you can see, when we run the laser run program, which is kind of the complete program, the laser turns off. Now we just start the rotation. So now we are scanning again. So we can just look at the, as you can see, we are just, this encoder counts just shows the times when the laser turns on, and then it scans the data. Okay, so we have finished the scan. Now the arm starts to rotate back. As you can see, but this time, because we are not doing the piecewise linear fitting again, it's going to take much less time. So currently, it's finished. So as you see, previously it took, I don't know, around 3 minutes to do the piecewise linear fitting, but this time it was finished maybe in 10 seconds, everything. So now we just, again, because everything was on the PC, we just upload the data. And again, as you can see, the robot is returning to the home position. So we just upload this time it's called Z2 because that's number 2 is the number of the scan. Just upload the data. Okay, now we just send the parameters again, and we should double check because again these programs are running separately on PC and Raspberry Pi. We should make sure in here the seam number is the same, the scan number is the same. And now just send the data, and as you can see the numbers are changing, like as you can see R2, R3, R5 and R6 because and if you see the LED blinked once, the reason these numbers changed because we have a weld now, so we are having different numbers. And to just make sure we are receiving the data, we are sending multiple times, but essentially usually the first time is okay, but just to make sure. So now we want to just do the welding of the the second pass. So we do it again, like we just set the angle, it's like -45, and we just decrease the speed. Mm-hmm. Yeah, and then we just, yeah, we just go to welding mode because continue run scan mode. We go welding mode, and the arm extends again, and the slider becomes in control mode. Okay, now if we just start rotating, yeah, we just move the camera near. So before getting to the kind of second welding part, it's not in, I mean it doesn't, because the only data we have is that for that part, but from when we reach there we can see that, okay. So yeah, because what we put there, it's very bumpy, because like tapes and some parts, it's not like it has at many parts it's uneven. That's why just the height is changing a lot, but essentially it's trying to just keep the same distance from the surface. And then it again returns to home position. So that's essentially kind of a multi-pass. So we are showing two passes here, but we can continue up to as many passes as we want. The only thing, the procedure between the first pass and the second pass and afterwards are a bit different. And this first pass we are scanning the groove when there are nothing, so we need to do the piecewise linear fitting, while in the next ones we are just detecting the welds from the previous passes and then controlling the arm based on that. So that's why we don't show the third and fourth passes, but because they're essentially the same thing, but we can do, for example, add more stuff, and then we can see that it works. Okay. I did it touch. Okay, some config. Okay, yeah, so afterwards we can just press home config. With home config, everything returns, like the arms and this stuff, everything returns to the home configuration. And then if we just do a start rotation, it just returns to the kind of 0. So it's because at home, when it's at home position, because the motor is still engaged, so we cannot turn it off. But yeah, when we do a start rotation again, we just go back to the equilibrium point, and then we can turn off the motor without any problems. Otherwise, your motor will fall. And yeah, when our theta measured is around 0, we just turn it off, and then that's done. So we turn off the robot at equilibrium. Yeah, that's it. And then we just turn off the motor, and then that's it. Yeah, thank you.